All right, let's go.
Number 7. Cherenkov Radiation. Things already move faster than light, just not in a vacuum. Here's the sentence that gets misunderstood constantly. Nothing can travel faster than the speed of light. That is not quite what physics says. The actual rule is nothing can travel faster than the speed of light in a vacuum, 299,792,458 meters per second. That number is fixed, but light does not always travel at that speed. When light enters a medium, water, glass, air, it slows down. Light in water travels at roughly 75% of its vacuum speed. Light in glass slows even further. Particles do not have to obey that slower local speed limit. A high-energy particle, an electron ejected from a nuclear reaction, for instance, can move through water faster than light moves through that same water, while still moving slower than light's vacuum speed. This is called Cherenkov radiation. It is the eerie blue glow you see in photographs of nuclear reactor cooling pools. Particles from the reactor core moving through the water faster than light can move through that same water. This is real, measured constantly, used deliberately in particle detectors around the world, including the Ice Cube Neutrino Observatory buried in Antarctic ice, which detects neutrinos specifically by watching for the faint blue flashes of Cherenkov radiation produced when a neutrino occasionally interacts with the ice. It does not break relativity. The particle never exceeds light's true vacuum speed limit. But it is proof that the speed of light is not one number. It depends on what light is moving through, and other things can move faster than light does in that specific place without breaking any law of physics. Number 6. The expansion of the universe. Galaxies are receding faster than light right now. This is the most commonly misunderstood exception in all of cosmology. The universe is expanding, not objects moving through a fixed space. The space itself is stretching. Every point in the universe is moving away from every other point, and the further apart two points are, the faster the space between them is expanding, following a relationship called Hubble's law. Because the universe is vast and because this stretching effect adds up across enormous distances, there exists a distance beyond which galaxies are receding from us faster than the speed of light, right now, not hypothetically, confirmed. The cosmic light horizon, roughly 4.5 to 16 billion light-years away, depending on how you define the boundary, marks the point where a galaxy's recession velocity, driven purely by the metric expansion of space, exceeds 299,792,458 meters per second. This does not violate special relativity. Einstein's speed limit applies to objects moving through space. It says nothing about space itself expanding. Nothing is physically traveling through the universe faster than light. The distance between 2 points is simply growing at a rate that light's ability to cross it. The practical consequence is enormous. Light from galaxies beyond the cosmic event horizon, emitted today, will never reach us, ever. The space between us and them is growing faster than the light can close the gap. And critically, during cosmic inflation, in the first fraction of a second after the Big Bang, physicists believe the universe expanded at a rate vastly exceeding the speed of light. Regions of space that started out close together were separated faster than light could have connected them. The entire observable universe passed through a period of expansion that broke the speed limit in exactly the sense that special relativity says is allowed. Number 5. Quantum entanglement. Correlation faster than light, just not communication. Two particles can become entangled, sharing a single quantum state regardless of the distance between them. Measure the property of one particle and the correlated property of the other resolves instantly, not after a delay calculated from the distance between them, instantly. Confirmed experimentally across distances exceeding 1,200 kilometers using the Chinese Messias satellite in 2017 and multiple times since with increasing precision. Einstein called this spooky action at a distance. He found it deeply uncomfortable because it seemed to violate the spirit of relativity, even if it did not violate the letter of it. Physicist Michio Kaku has explained it directly. If you have two entangled electrons and you disturb one, the other electron senses that disturbance instantly, faster than light could travel between them. The correlation itself moves faster than light. This part is not disputed. Here is the part that saves relativity. You cannot use this to send a message. The outcome of measuring an entangled particle is fundamentally random. You cannot control what result you get. You can only see the correlation after the fact by comparing your result with the other observer's result through an ordinary light-speed limited communication channel. Until that comparison happens, the data on your side looks like meaningless noise. No usable information, no message, no signal, no instruction can be transmitted through entanglement faster than light. The correlation is real, instantaneous, confirmed by physics, and it cannot carry a single bit of controllable information. It is a loophole that leads nowhere. Number 4. Tachyons. Particles that have never been slower than light and have never been found. In 1967, physicist Gerald Feinberg formalized a theoretical particle called the tachyon. Its defining property is not that it accelerates past the speed of light, it is that it has always been faster than light. Under the mathematics of special relativity, a tachyon would have imaginary rest mass, a mathematical quantity that does not correspond to anything physically sensible for ordinary matter, and it would only be able to exist at speeds greater than c. It could never slow down to the speed of light or below, the same way ordinary matter can never speed up to reach it. The equations of special relativity do not strictly forbid tachyons from existing as a mathematical category. This is important. Einstein's relativity says objects with real, positive mass cannot accelerate to or past light speed. There is an infinite energy requirement in the way. It does not say that a completely separate category of particle, one that starts out faster than light, is mathematically impossible. But a genuine tachyon would create serious problems with causality. If tachyons exist and interact with ordinary matter, in certain reference frames, they could be used in principle to send a signal into the past. Cause and effect could be reversed for some observers. This is precisely the kind of paradox that special relativity was built to prevent. No tachyon has ever been detected. Every experimental search, and there have been many, across particle accelerators and cosmic ray observations, has come back empty. Most physicists regard tachyons as a mathematical curiosity rather than a real physical possibility. But their existence is not strictly forbidden by the equations. They occupy a strange gap between what the math permits and what nature appears to actually contain. Number 3. Phase velocity and group velocity. Some waves do move faster than light, they just carry no information. This one is subtle and it trips up even people with a physics background. A wave has multiple velocities that describe different things about it. Phase velocity describes how fast the crest of a wave pattern moves. Group velocity describes how fast the overall envelope of a wave packet and the information or energy it carries actually propagates. Under specific conditions, particularly in what is called anomalous dispersion, the phase velocity of a wave can exceed the speed of light. This has been demonstrated experimentally. It sounds alarming. It is not. The phase velocity is not a signal. It is not energy moving through space. It is a mathematical description of how the pattern of peaks and troughs within the wave shifts position. You cannot attach a marker to the crest of the wave and use it to send information because the crest itself is not a physical thing traveling. It is where multiple underlying components of the wave momentarily reinforce each other. The reinforcement pattern can shift faster than light, without any actual energy or information making that same journey. In 2000, physicists Li Jinwang, Alexander Kuzmich, and Arthur Dalgariou conducted an experiment using specially prepared cesium gas that produced what was reported as a light pulse with a negative group velocity, appearing, under a specific and heavily qualified reading of the data, to exit a chamber before it had fully entered. The result was real and published in Nature. It generated significant media excitement, and it generated equally significant clarification from the physics community. No actual information traveled backward in time or faster than light. the pulse was reshaped by the medium in a way that made its peak appear to shift, without any single photon or any usable signal exceeding the light speed limit. Phase velocity and group velocity anomalies are consistently cited as apparent counterexamples to the speed of light. They consistently turn out, under close examination, to preserve it. Number 2. Warp drives, a mathematically real solution that might not need impossible physics anymore. In 1994, physicist Miguel Alcubierre, then at the University of Wales, Cardiff, published a solution within the framework of Einstein's general relativity that produces something remarkable, a way to move faster than light without ever locally exceeding the speed of light. The trick is not to move a spacecraft through space at superluminal speed, it is to warp spacetime itself. Contract spacetime in front of the ship, expand it behind. The ship sits inside a bubble of flat, undistorted space, moving at ordinary sublight speed relative to that bubble. But the bubble itself, carried along by the contraction and expansion of the spacetime around it, can travel between 2 points faster than light could travel between those same 2 points through ordinary space. This does not violate special relativity for the same fundamental reason cosmic expansion does not. Special relativity governs objects moving through spacetime. It says nothing about spacetime itself being reshaped. The Alcubierre metric is a legitimate, peer-reviewed solution to Einstein's field equations. For 30 years, the fatal problem was the energy requirement. The original Alcubierre solution required exotic matter with negative energy density, a form of matter that has never been directly observed in usable, sustained quantities. And it required roughly the total mass energy of an object comparable to a planet or star, a completely impossible engineering requirement with any physics available. Then, in May 2024, a research team re-examined the mathematics with a different question. Could a version of the Alcubierre warp bubble be constructed using only positive energy, ordinary matter and energy, the kind that makes up planets and people, rather than exotic negative energy? Their answer, published in Classical and Quantum Gravity, was yes. They demonstrated a physically viable warp drive solution that does not require negative energy density at all, though it comes with a significant trade-off. Their solution does not allow superluminal travel outright. It describes subluminal warp configurations, space-time engineering effects using only conventional physics. It is not yet a faster-than-light drive you could build. It is the first time in 30 years that the exotic matter requirement, the single biggest theoretical obstacle, has been shown to be avoidable at all. The mathematics of moving faster than light without breaking relativity's local speed limit has gone from requiring physics that has never been observed to requiring physics we already know exists. Number 1. Wormholes, the shortcut that might be more efficient than any warp drive. If a warp drive moves a bubble of space from one point to another, a wormhole does something different. It connects 2 distant points directly, folding spacetime so that a short tunnel joins 2 regions that would otherwise be separated by an enormous distance. The mathematics describing wormholes, technically Einstein-Rosen bridges, emerged from Einstein and Nathan Rosen's own work in 1935, originally intended to describe elementary particles rather than travel shortcuts. Physicist Kip Thorne and his students later worked out the conditions under which a wormhole could in principle be held open long enough for something to pass through it. That condition, like the original warp drive, requires exotic matter with negative energy density to prevent the wormhole from collapsing on itself instantly. Here is the detail that changes the calculation entirely. Once a wormhole is created and stabilized, it does not require continuous energy to use. It is a shortcut. You do not need to accelerate to any speed at all to benefit from it. You simply pass through the existing tunnel, and the distance across ordinary space is bypassed completely. Recent theoretical work comparing the energy costs of wormholes and warp drives directly has found that wormholes are dramatically more efficient. Creating a faster-than-light wormhole roughly 100 meters in diameter has been estimated to require approximately 10 to the 46th power joules of negative energy. Applying that same quantity of energy to a warp bubble of equal size produces a ship moving at only about 1% of the speed of light. The wormhole gets you an instant shortcut. The equivalent energy invested in a warp bubble barely gets you moving. Both concepts remain firmly theoretical. No exotic matter with sustained, usable negative energy density has ever been produced or observed at the scale either concept requires. The Casimir effect, a real, measured quantum phenomenon, does produce a form of negative energy density between closely spaced plates, but at a scale so small it offers no path to the quantities a traversable wormhole would need. What both concepts share with the expansion of the universe and with the Alcubierre warp bubble is the same underlying loophole. None of them require anything to move through space faster than light. They all require space itself to be reshaped. Special relativity's speed limit was never a limit on space-time, only on what moves within it. 7 exceptions. Particles already moving faster than light through water, producing the eerie blue glow inside nuclear reactors. Galaxies receding from us faster than light right now, carried by the expansion of space itself. Entangled particles correlating instantly across any distance, while still refusing to carry a single bit of usable information. Tachyons, never detected, never proven impossible, sitting in a mathematical gap nobody has closed. Wave patterns whose crests can outrun light while carrying no energy and no signal. A warp drive equation from 1994 that in May 2024 was shown for the first time to potentially work without physics that has never been observed. And wormholes, a shortcut through space-time itself, dramatically more energy efficient than any warp bubble, requiring nothing to travel faster than light, because nothing has to travel through the space in between at all. The speed of light has never actually been broken, not once, not by anything ever measured. But the loophole running through every single one of these exceptions is the same loophole. The limit was never on speed, it was on motion through space-time. Reshape the space-time instead, expand it, warp it, fold it, and the rule was never written to stop you. Subscribe to Cosmic Hives. See you in the next one.